might use something called the quadratic formula to solve quadratic equations. Notice our quadratic equation here is written in the form ax squared plus bx plus c equals 0. If you can get your quadratic equation to have one side equal 0, you can get it in that form, then we actually know what x is equal to. It is the opposite of b, or negative b, plus or minus the square root of the quantity b squared minus 4ac, all divided by 2a. You may have encountered this formula before. I'm going to talk a little bit about how we use it, how we plug in, and we're going to do about 3 examples and see what the numbers might look like. Some things to notice about this formula is that the entire expression b squared minus 4ac, notice that is entirely underneath the radical symbol. Also, notice the 2a is underneath the both terms in the numerator, so it's that whole thing divided by 2a. It's tempting sometimes to forget that the whole numerator is the whole numerator. It's tempting to just maybe divide part of it by 2a. So let's see how we could actually use this in action. Notice we can't use the quadratic formula yet because this does not look like ax squared plus bx plus c equals 0. We have x squared minus 5x equals negative 1. Luckily, all we have to do is add a 1 to get it in the form that we want. Here is our new equation that we can use the quadratic formula for. I know that we have to identify a, b, and c before we plug in. Notice a is the coefficient in front of the quadratic term. In this case, a is 1. B is the coefficient in front of the linear term. In this case, it is negative 5. And c is our constant added on to the end. In this case, it is 1. Hopefully, since it's on the last page, hopefully you have the quadratic formula memorized. If you don't, that's something that's really handy to just know offhand. I don't know if you'd have the time to derive it every single time you want to use it, so it's kind of nice to have it memorized. Since b here is already negative, if we're looking for negative b, that's going to be a negative 5, which is going to end up being positive 5. Plus or minus the square root of b squared minus 4 times a times c. It's kind of our lucky day because a and c were both 1, so that's not so bad to plug in. All over 2a. You might be able to do part of the substitution in your head. For example, the quantity negative 5 squared is a positive 25, but I wanted to write out the expression showing the substitution so you could really follow along clearly. Of course, I'm going to switch colors now so it's easier to read. Of course, negative 5 is positive 5. And then we have plus or minus the square root of negative 5, the quantity squared, is positive 25, minus 4 times 1 is just minus 4. All over 2 times 1 is just all over 2. What's important to note is that b squared, whether b is positive or b is negative, b squared is always, always, always positive. That first number you're writing down in the radical, so here that's the 25 right here, that will always be a positive number, even if b was negative because we're squaring it. Let's keep simplifying. We get 5 plus or minus the square root of 21 all over 2. How many solutions is that? That's actually 2 solutions. 5 plus root 21 all over 2, and 5 minus root 21 all over 2. We can leave our answer like that. It's also important to note that if we wanted to, we could write our answer like this. That's the same thing. Notice I just divided each term in the numerator by that denominator 2. What we absolutely can't do, though, is combine the 21 and the 2, because it's the square root of 21. So we can't divide 21 by 2. We have to leave it in one of those 2 boxed forms. Either one is fine. Let's see how complicated it might get. Again, we can't use quadratic formula yet because we don't have one side equal to 0. But if we add the 2 terms on the right onto the left, or we move them over, we end up with 3x squared plus 2x minus 4 equals 0. A is 3, B is 2, and C is negative 4. we can now plug in to the quadratic formula. X equals negative b, in this case that's a negative 2, plus or minus the square root of b squared, so that's going to be a 4, minus 4 times a times c. So I didn't write out 2 squared, I just wrote out 4 for that first part. I did that in my head, but I did show the substitution for the other two numbers. Let's keep simplifying. Notice I put the c value, the negative 4, in parentheses. It's going to be really important. Let's see what we get now. Be careful about order of operations. We would not do 4 minus 4. We would figure out 4 times 3 times negative 4, and then subtract that. 4 minus, let's see, 4 times 3 is 12. 12 times negative 4 is going to be negative 48. Look what happened when c was negative. Inside the radical, we ended up subtracting a negative number. That's really addition. This is going to be the part where it's easy to make mistakes. We're just plugging in, but be careful about subtracting a negative number. This ends up being negative 2 plus or minus the square root of 4 plus 48 all over 6, which is negative 2 plus or minus root 52 all over 6. So notice when c was negative, b squared minus 4ac, well, if c is negative and a is positive, then 4ac itself ended up being negative. And when we're subtracting that, we're really adding. So be very, very careful about subtracting negatives. You can leave your answer like this, or you might remember from maybe geometry or algebra 1 that we can reduce the square root of 52. The square root of 52 is really 2 root 13. Notice we could keep simplifying this. We could call it negative 2 over 6 plus or minus 2 root 13 over 6. And we can simplify that a little bit further, negative 1/3 plus or minus root 13 over 3. All we did was we reduced the fractions 2/6 and 2/6 into 1/3 and 1/3. This answer that I've put in the box is really the simplest form, I think, of our answer. But if you left your answer like this, that's probably okay. You just don't have a reduced radical. You don't have a simplified answer. Probably anything after that first box, any of those answers are fine. It's just important to know that we can reduce that radical root 52. This is our last example that we're going to look at on these notes. Notice we don't have to manipulate it. We already have ax squared plus bx plus c equals 0. A is 2, b is 1, c is 1. Let's plug in. X equals negative b plus or minus the square root of b squared. 1 squared is just 1, so I'm just going to do that part in my head. Minus 4ac all over 2a. Let's see, let's simplify what we have in the radical. 1 minus 8, since 4 times 2 times 1 is 8 all over 4. And you might notice that we get a negative number inside the radical. 1 minus 8 is negative 7. This is the first example we've seen where that happens. What does this mean? How can I take the square root of a negative number? Well, if we're sticking with real numbers, we can't. Root negative 7 is not a real number. Think about what it means to take the square root of something. I need to find a number so that when I multiply it by itself one time, I get that number under the radical. And there's no real number times itself that'll give us negative 7. So the square root of a negative number is not real. So we would say at this point that there is no real solution to this equation. Now, in a few days, we might see some examples where we do have some sort of solution to this equation, but it won't be a real number. There is another number set out there outside of real numbers that we haven't really talked too much about, and you might already know a little bit about those number set, those kinds of numbers. But for now, if we get a negative under the radical, we can just say that there's no real solution since we haven't yet talked about that number set. But later on, we will go a little further with this. So this might be a problem we put on the back burner. For now, we say no real solution, but later on we'll figure it out. So that's 3 examples of how you would use the quadratic formula. I would say the biggest thing you have to be careful of is your negative signs. Be careful about plugging in. Other than that, it's really not so bad. Good luck.